So anyways, so that's 6 minus 4x equals 11x. Is that right? Add 4x to both sides. 6 equals 15x. So what is x? Well, the other way around, 6 over 15, or 2/5, right? Good? Yeah. So we started talking about graphs on Monday, and so there's a very special type of graph we're going to focus on. So we're going to focus on, well, equation of a line and just linear equations with two variables. So every time we're dealing with any equations with two variables, the only way to solve them is to graph them. And we really want to cut down on our graphing process. All this plotting point business takes forever. So we want to know how to graph it fast. So linear equations are pretty straightforward because the graphs are lines, and lines are easy to graph. And if I tell you, here's the point, how many lines can you draw through that point? A lot, right? You can just keep going, going, going. But if I give you one more point, how many lines can you draw for those 2 points? Just one, right? So you need 2 points to define a line, or you need a unique line passes through any 2 points. So when graphing a line, all you really need is 2 points. So here's a general form of a linear equation. That still has 2 variables. Something like this: ax plus by plus c equals 0. So the key is that x does not have any exponents, y does not have any exponents, a, b, and c are just some real numbers. So every time the graph of this equation will be a straight line. And in order for me to graph a straight line, I just need 2 points. And the easiest 2 points to find, usually, are the ones that hit the x-axis and the y-axis, okay? So first we're going to talk about the x-intercepts and the y-intercepts. So let's say you have a graph that looks something like that, whatever. What? Why not? So what? I'm not saying it's a graph of a function, it's just a graph, right? And I can graph a circle. It's pretty and good looking, but doesn't pass the vertical line test. But yeah, you're right. If I called it a function, then I would be full of, you know what. But I didn't. I just said it's a graph. I can do whatever I like, right? So every time a graph hits the x-axis, we call those points x-intercepts. All of those points right there are x-intercepts. What do they all have in common as far as their coordinate goes? What is the y? Well, not really. x is actually, y is always 0. So good observation. Y is always 0, right, on all of those points. So in order for us to find the x-intercept, all we have to do is to set y equal to 0 and solve for x. That's the idea. So to find x-intercepts, set y equal to 0 and solve for x. The good news with the linear equations, most of the time you're only going to get one x-intercept. Sometimes you'll get none if your line is parallel to the x-axis. Sometimes you get many if your line overlaps the x-axis, but that's just silly. But most of the time, it's just one. So that's the x-intercepts. Now the y-intercepts are all those points that hit the y-axis. So yeah, when you're going to study the concept of a function, and that's what Matt was talking about, you're only going to get one y-intercept. You never get more than one. But these are the y-intercepts. So let's drag them here. The y-intercepts. So just like with the x-intercepts, the common theme here is that the x value equals 0 for all those points. So in order for us to find the y-intercept, we can set x equal to 0 and solve for y. Okay? So again, with linear, with lines, you most of the time just get one y-intercept, only crosses the y-axis at one point. Sometimes you get none if it's parallel to the y-axis, but most of the time it's just one. Is that okay? So with that, I can do a graph pretty fast. So when I have this equation, let's say 2x minus 3y plus 12 equals 0. Let's say something like that. Make it friendly. Okay? And I can ask you solve this equation, which would be equivalent to asking you just grab this equation. So you need to find any 2 points that satisfy that equation, and usually the easiest ones are the x and y intercept. You plug 0 for x, solve for y. You plug 0 for y, solve for x. You'll get your 2 intercepts, and then you connect the dots. Okay? I'm sure at some point, whoever was teaching you how to do the lines, they told you find 3 points, just to be safe. Make sure they are all on the same line. I trust you. Just do 2. You should be at the point where you can comfortably find the 2 points correctly. So yeah, find x and y intercepts. So for x-intercept, set y equal to 0. So the way I like to do that, you can do it in your head. Just cover the y term, so you have 2x plus 12 equals 0. Right? That's what it means to set y equal to 0. So can you solve that equation? If you do that, this is just 2x plus 12 equals 0. So 2x, what? So what is x? Negative 6. So that's the x-intercept. X equals negative 6, or the coordinates is negative 6, comma 0. That's that point on the plane, negative 6, comma 0. Now the y-intercept, we will set x equal to 0. So it's the same story. Just cover everything that got x's, and you're left with negative 3y plus 12 equals 0. And then solve that for y. Right. So divide by negative 3, divide by negative 3. Y equals 4. Or 0, 4, because that's on the y-axis. Now x is 0, y equals 4. So now you have 2 points, one on the x-axis, one on the y-axis, and that's enough to graph a line. So I can actually now go ahead and do this. The y-intercept was 0, 4, so 1, 2, 3, 4. The x-intercept was negative 6, 1, 2, 3, 4, 5, 6 on the negative side. So here are the 2 dots, connect them, and you got yourself a line. Okay? Happy? Happy. Now, as a side note, we really don't like when equation of a line is expressed in the general form. It's one of the most unfriendliest form. We don't like that form. There are better ways to think about the line. But so far so good. You need 2 points to draw a line. Okay? All right. Well, now let's talk about this other idea. So if I give you just 1 point, you can draw infinitely many lines through that. But if I tell you what? If I tell you this, think about the line that is heading in that direction. Heading, what is it, northeast? Think about a line in northeastern direction. How many lines can you think about that heading in a northeastern direction? Tons? Yeah, right? You know, that one, that one, that one, that one. They're all heading in the northeastern direction, right? So kind of the same thing. If I give you 1 point, you can think about infinitely many lines going through that point. If I just give you a direction, you can think about infinitely many lines going in that direction. But what if I tell you that I want you to think about a line that passes through this point and is heading in a northeastern direction? How many lines do you have that go through that point precisely going northeast? Precisely northeast. 1, right? There's only 1 line that will go northeast, right? It's kind of like that. So there is another way to think about the line. If you're given a point that the line passes through and a direction in which that line is going, you get yourself a unique line. So there is another way to think about the line. Not just 2 points, but a point and a direction of a line. So alternatively, and I'm not going to spell that word, so I'm going to stop now. A point and direction define a unique line. Okay? Now this thing about the direction, we want to learn how to measure it precisely, because this whole north, east, south, southwest, you know, that's very limited, right? Because if I want to do some really funky thing, I'll have to do like 7 souths, couple norths, 7 easts, and 2 wests, 2. Okay, that's probably not going to work, but you know what I'm trying to say. So I want to know, how can we define a direction in this case? But really, you can think about this. You know, here is a point, and the line's going that way, right? And if you think about, all right, so here's the point, and there's a direction. And if you have another point on that line, then you can think about the direction of that line as some kind of a ratio between its horizontal shift and the vertical shift, right? If I tell you that for every 2 steps you move horizontally, the line goes up 3 steps, that's a pretty nice way to define a direction of a line. Let's say for every 2, it goes up 3. Right? There's a pretty unique direction. So we can actually quantify that very precise. Actually, the northeast direction will be for every 1 step you take horizontally, you have to move 1 step vertically. So that's kind of a 45-degree slant or whatever. So I think you all kind of look at me like I'm a crazy person, because you probably know what I'm driving at, right? There's a name for that thing, slope of a line. But that's what slope is. Tells you the direction of a line. And it is a ratio of the vertical shift to horizontal shift. So, good. So, slope. It's nice when, I have no idea how to teach it cold when people haven't seen a slope. Right? You all seen a slope before, right? Okay. But I cannot imagine doing that if you haven't. Well, I guess that's how you do it. You just go, well, let that be slope, and turn the light on. So, the slope. We usually use the letter M to represent the slope, and the slope is the ratio of the vertical shift to horizontal shift. So that's change in y over change in x. Okay? Or some of you like to call it rise over run. Right? That one, you've heard that one before? Do you know a cute mathematical way to represent word change? Yeah, capital delta, very good. So I can write it as delta y over delta x. So we use capital Greek delta to stand for change. Okay? And if you have 2 points, then you just subtract the y values, y2 minus y1 over x2 minus x1. So that's the official mathematical formula. So here are my 2 points. First one was x1, y1, and the other one was x2, y2. So you subtract the y values, subtract the x values. So the ratio of those two. So if I give you 2 points, you can find the slope of the line. Okay? Is that right? So basically this whole story comes down to all you need is a point on a line, any point, and the slope of that line. And it will give you a very unique line, and we'll be able to find the equation of that line, we'll be able to graph it, and we can just go crazy with that thing, right? What? Well, that's kind of a big deal for us too. The whole idea of a slope of a line drove the human civilization forward by a bunch. If we stuck with that, we would still be, I don't know where. I don't know. What would be a, I don't know, in caves maybe? Sure, we'll just be drawing that. But the fact that we can think about this stuff and we can realize that there's a connection between how fast the level, how fast the line is rising or falls is actually quantified by the slope, that there's a connection between the slope of the line and the rate of change in which something changes. And then automatically you got yourself an internal combustion engine and your iPhone, and then and so the Industrial Revolution goes boom from there. The second you have that connection between the rate of change, and then kind of have to do a lot with that. So yeah, so that's your iPhone right there. That fun? Well, yeah. No. Every time it breaks because it's still a piece of crap. But anywho, so if I give you 2 points, you should be able to find the slope of that line. That's basically the story, right? Now, if the slope comes out, if this, it's okay. If the slope comes out positive, the line is heading upward, so things are moving forward, things are going up. If the slope is positive, if the slope is negative, things are going down. You know about that? If the slope is 0, what is it going to look like? Horizontal, right? And if it's vertical, then what's going on with the slope? What? What's the value of the slope of a vertical line? Oh, that's the horizontal line. 1,000,000? No, 1,000,000 is that. How about this? Vertical. Well, let's think about this. The horizontal line, right? So that means what is the change in y as you move along the horizontal line? 0, right? The y doesn't change. So if you look at this formula, it is 0 divided by who cares equals 0. So that's why slope of a horizontal line is 0. But if you look at the vertical line, what is the change in x as you travel along the vertical line? 0, right? So change in x is 0. You got yourself 0 in the denominator. Can you have 0 in the denominator? No. So the slope of a vertical line is undefined. Doesn't have a slope. Or, 1,000,000 and then a whole bunch more, because it just basically goes to infinity type of thing. Okay. So in general, these are positive slopes. I shouldn't have done the little error on my line. So this is positive slopes. These are negative slopes. Horizontal lines, slopes equal 0. So those don't usually have x-intercepts. They're most likely going to be parallel to the x-axis. And the vertical lines, slope is undefined. Is that okay? All right, now finding the slope. So if I give you 2 points, for example, 3, 2, and 4, -2, we can find the slope of a line that passes through those 2 points without too many problems. So we do change in y by change in x, so that's -2 minus 2 over 4 minus 3, right? So that is -4. You have to really watch your signs here, over +1, so that's -4, okay? So what that means is that when your change in x is 1, your change in y is -4. Okay, that's the direction. So if you take 1 step in the x direction, we always like to move in a positive x direction. You take 1 step in the positive x direction, you're going to go 4 steps down in the y direction. Pretty steep, right? So I can actually do a quick graph of this line. Yeah, I can plot these 2 points. I'll be happy with that. But if I just use, let's say, the first point, 1, 2, 3, and 1, 2, 3, 2, the slope of -4 means it goes down 4 and over 1. So that's the line. Well, close enough, right? So at some point on that side, yeah, that's right there is 4, -2, by the way. but that's the idea. You start at a point, and then you interpret the slope. The numerator is the y, the denominator is the x. X is always positive. Let's just do that. It'll be easy if we always move in a positive x direction. And then depending on the sign, you either go up on the y or down on the y. If it's positive, you go up. If it's negative, you go down. Good? All right. How about these 2 points? 3, 6, 5, -7. So there's a unique line that passes through these 2 points. I just want to find the slope of that line. So m equals -7 minus 6 over 5 minus 3. And it's really important that you stay consistent as far as the point from which the numbers come from. Okay, so here's 6 and 3, they came from same point. Here's -7 and 5, they came from same point. They have to be lined up like that. You can switch the first and the second point. So they'll switch everything. It'll still get the right answer. But if you flip one of those, you're going to get the wrong sign. So it's very important to stay consistent. But anyways, looks like it's -13 over 2. Right? What does that mean as far as the line goes? How would you interpret that as a direction of that line? Right, negative slope, but how precisely? So down 13 and to the right. So again, if I start at this point, which let's say is 3, 6, right? So in order for me to get to the second point, I have to go 13 down and 2 over, right? So if I do that, what's that other point? I went 2 over, so x is 5, and I went 13 down, so -7. Oh, look at that. It's that point. Lucky. Right? Does the idea make sense? How about this example? 2, 8, negative, how about 2, negative 8, and then negative 4, positive 4. So I want to find the slope. So that's change in y. So 4 minus negative 8 over change in x. So it's negative 4 minus 2. So what is in the numerator? 12. Because 2 negatives give me a positive. So it's 4 plus 8. So that's 12 over negative 6. I don't know, all my slopes today come out negative for some reason. So negative 2. So it means 2 down, 1 over. Okay? Is that all right? Happy? Did you learn something new? No, you're supposed to say no. You haven't learned anything new. It's all old. You knew that. Right? Nothing? Everything's new? It's okay. All right. Well, now let's talk a little crazy then, if you feel so comfortable. So let's say given a point on the line, given a point, let's call it x1, y1. So here's that point. Let's say x1, y1. And slope of that line, m. So we have a point on that line, and we have the slope. So let's say interpreting the slope, we were able to graph the line. So here we go. So here's the graph of that line, right? If I just have a slope on a point, you can sketch the graph really fast, like we did before, right? You start with a point, and then you interpret the slope. Well, so that would be a solution to some equation. This graph would be a solution to some equation. Well, can I find that equation? Can I find an equation which this graph solves? All right? And the way we do that, because you have to understand something, no matter what 2 points I take on this line and I try to compute the slope, it's going to be the same no matter what 2 points I take. You agree with that? No matter which pair of points I take, I'm always going to get the same slope, as long as it's on the line. So that means it doesn't matter which point I grab, I'm going to grab this point. Arbitrary point. Could be anything. So that point is really a variable. It could be any point, so I'm just going to call it xy. Right? Well, then I have the following. M equals change in y over change in x, so that's y minus y1 equals x minus x1. So that's the slope of a line between an arbitrary point xy and the fixed point x1, y1. By the way, for the future reference, every time you see a letter with a subscript, like x1, x2, x3, that means that thing is fixed. It's no longer a variable. Every time you see an x or y, those means those are variables. So it could be anything. Is that okay? Usually if you see A's, B's, and C's, those are usually constants. Nobody cares about them. But those fancier ones, X, Y's, and Z's, subscript means it's fixed. Okay? Doesn't have any mathematical meaning. Is that me? Uh-oh. Sorry. Who is that calling me? I think it's the college. I'm not going to answer that. They should know better. I'm in class. Oh, I just answered that. I wanted to hang up. Let me turn it off. I had this policy back in the day. I don't know if I still have it. Is that on the syllabus? If your phone goes off, I get to answer it, and vice versa. If mine goes off, you get to answer mine. Yeah, and I totally did it every time, and I would make up some crazy stuff. And one day I spoke with the sheriff, so that wasn't good. I stopped doing that after a sheriff called one of my students. That was because I was like, "Hey, would you like pepperoni on your pizza?" type of thing, and the guy was like, "What?" So, are we okay with that? I can rearrange it algebraically if I just multiply both sides by that denominator. I can rewrite this expression as y minus y1, which is the numerator, equals m times x minus x1. Right? So this right there is equation of a line. That's equation of a line that passes through a point x1, y1 and has slope m. And we have a special name for this equation. We call it point slope form, because it has a point x1, y1 and it has a slope m. Point slope form. Okay? So you need to know that equation, by the way. That's kind of a big deal. Now, if I start simplifying this, if I distribute m, I'll get mx minus m times x1. Right? If I distribute m through, I'll get that. And if I solve for y, I'll have to add y1 to both sides. I have this. Y equals mx plus y1 minus mx1, something crazy like that. I don't know if you should be writing this part down. But all I did is just open up parentheses, solve for y. Well, now let's talk about what we have in front of us. This thing right there, this lonely y, that is a variable, right? It's a variable y. That's my dependent variable. No subscripts. What about m? Is m a variable or a constant? It's a constant. That's a slope that was given to me, right? That's a constant. Now, how about this x? Is x a variable? Variable. But now, how about y1? It's fixed, so it's constant. M is a constant and x1 is a constant. So this whole thing right there is a constant. One big constant. Right? And since we call the big constant, we're just going to call it b from now on. This whole thing is b. I just totally made that up. That's not why that part is b, but we can always think of equation of the line as mx plus b. Mx plus some big constant. I like that. I'm going to use it from now on. All right, so mx plus b. So that's another way to think of equation of a line. So what does that equation tell me? It tells me the slope of the line. What? I like that too. I should just use that from now on. Just made it up. Wow. So it tells us the slope, so that will have a slope in its name. But what is that b? What is that b constant? If I ask you, can you find the y-intercept of this equation? Remember how we do y-intercept? We said y equal to 0. So if you said y equal to 0, I'm sorry, did I say y? I meant x. To find y-intercept, we said x equal to 0, so you'll just have y equals b, right? So b is the y-intercept, so it's slope-intercept form. So b is the y-intercept of that line. So this right there is the friendliest form of the line, because it tells me everything I need to know about the line. It tells me one of the points, which is the y-intercept, boom, right there. I know where it's going to cross the y-axis, whatever the b is. And it tells me the slope, because that means I know where it's going. So I can sketch the graph really fast. That means I can solve equations almost instantaneously. That's big, right? So for example, if I write something like this, y equals 2x minus 1, that is a linear equation that is written in mx plus b form. I see that constant, -1, -1 is the y-intercept, automatically. -1, that's the y-intercept. 2 is the slope. So I can go ahead and sketch that line really fast. Because all I need is a point and know where to go from that point. So automatically, we start at -1 on the y-axis. That's the y-intercept. And the slope is 2, which means go up 2 over 1. Here's my other point. So bam, that's the line. Fast, right? Wouldn't have to do any plugging in numbers or anything like that. No tables. Give us that fast. Did you like that? You've done that before, right? You think? Or okay. I'm pretty sure you have. But anyway, so that's the idea. So if the line is written in the form mx plus b, we can sketch that graph really fast, because that form tells me right away the value of the y-intercept, and it tells me right away where to go from there. The slope will tell me the direction in which I need to go. So y-intercept is 2. The slope is -2/3. The way we interpret that is you would go down 2, 1, 2, over 3, 1, 2, 3. That's the second point. So bam. Make sense? This is good stuff. I like that. I should post it on YouTube. That thing will go viral because it's so awesome. The way we derived that form. I'm almost proud of myself.